Hi everyone, and welcome to the video on the Open API spec. This is something we've been delaying for a while because this isn't a super useful thing, but it becomes useful if you're thinking of building a website where you want other developers to directly hit your backend servers. I repeat, when do you need the Open API spec? When does it become important? If this is your backend application, let's say written in Node.js, and you have a front end for it. For example, let's say this is Binance.com front end, this is Binance.com backend. The front end will of course send requests to the backend, but you might want if there is a trader somewhere, that trader can directly hit the backend of Node.js without interacting with the front end. It's a fairly common use case if this is a trading application, even Zerodha, not even Binance, Zerodha, Grow, any trading application, a lot of times needs traders can directly hit the backend of the application. Traders should not need to go through a UI and click a few buttons. When you're building an application like this, when you want to allow traders or anyone to hit your backend directly, OpenAPI spec becomes super useful. Binance is a great example because if you look at it, Binance has a page like this where they clearly expose if you want to trade programmatically, if you want to place an order without going through our UI, you can place a new order by sending us a post request to this endpoint with this body. When you're building systems like these, that where you want to allow other developers to directly hit your backend, you want to expose them your APIs in a very clean documentation page, OpenAPI spec becomes super useful. Let's see how it becomes super useful. Before that, why OpenAPI spec? Why do you need this? What does it provide? Let's say this is your Node.js Express server. What if you could create a single file that describes every endpoint of yours? I repeat, you have written a bunch of Express logic over here, app.get, app.post, app.put, app.delete, but you don't want other people to look at your code and figure out your endpoints. You want other people to look at, for example, a documentation page like this, which clearly shows this server exposes a /API/v3/order endpoint, /API/v3/order delete endpoint, /API/v3/open orders endpoint, so on and so forth. So what if you could write this all in a single file? There is a get route which takes a query param and returns something like this. What if you could describe all of this in a single file and give it to the developers, the traders? This is our endpoints that we support. Please send us requests on these endpoints. This is what we support in a single file. Rather than creating a page like this, a single file where you describe all of this. Harkirat, why a single file where I describe all of this? Why not just give them a documentation page like this? Because if you have this single file that has all of your endpoints in a certain format, you can always auto-generate a documentation page like this. In fact, I can almost guarantee that this page is auto-generated. All of these docs that you see come from a single either OpenAPI spec file or a different spec file. But usually the goal is, if this is your backend, you expose you just write down, this is the structure of my backend. There is a get endpoint at /API/v1/order, which takes a query parameter, returns this thing. Describe all of this in a single file. And then you can always auto-generate documentation pages, auto-generate clients. We'll get to what clients are. But that is one of OpenAPI spec is one of such ways to write everything in a file. When you create a backend, it's very hard for other people to know the exact shape of your routes. What is there a get endpoint, a post endpoint? What route should I hit? Wouldn't it be nice if you could describe in a single file the shape of all of your routes? For example, if you go to some server.100xsteps.com /todo ID = 1, it returns you to-dos that looks something like this. It gives you a random to-do with the given ID. What if you could describe this in a file like this? If you hit the /todos endpoint on a get route with a query parameter, it returns this. If you have the single long file that lists all of your routes, you could, if you are able to create this file that lists all of your routes, right now I've only listed one. Let's say you list all of them. You could auto-generate documentation pages. You could auto-generate clients in various languages. We'll get to what clients are, so feel free to ignore this one. Let the world look at your API routes shape without actually opening your code. Binance hasn't shared their Express code with the world. They have shared, okay, this is the routes that the Express code has. If you want to hit them, feel free to hit them. Harkira, so this is the security vulnerability. Then to anyone can look at the API routes. You can anyways look at these routes. If I go to Binance.com, it is banned in India right now, the front end. But if I go here and click on a trade, like the button that says trade, or I go to a different exchange, I go to Backpack Exchange, for example, and I click on this button, I can always inspect where does the request go out. So this isn't a security bug. They are just exposing कि भाई these are our endpoints. You can hit them. Of course, send me some credentials of yours along with it. कि हाँ, your cookie or your JWT, so I can identify you. But there is no security vulnerability here for them to expose this to the world. Let's AIs know how to hit your APIs in a single file without sharing your code with the AI. Another big benefit is if you go to chat.openai.com or any LLM, and if you try to create a plugin or talk to it, the AI can look at this file and understand that achha, this is the get endpoint, post endpoint, put endpoint, so on and so forth, and this is the shape, and the AI can send a request to your backend. So if you want to create agent server and you want to tell the agents that bhai, these are the endpoints that we support, you can either give the AI agent this documentation page or just give them a single file that has all of your routes. The agent will immediately understand that achha, these are the routes that I support. OpenAPI spec became popular when ChatGPT plugins came, and they expected that whoever is writing the plugin, wherever their backend is, they expose an OpenAPI spec file. So that is another use case. If you have seen this page at all ever, the Swagger page, this is also an auto-generated page. If you have this file that exposes all of your routes, you can, in a single command, generate this page. That gives you a Postman-like interface in your browser. We will create this in the last slide. So if you don't understand this, it's fine. But it gives you like a page where you can see all of your endpoints, expand this, actually hit the endpoint without using Postman. We'll get to this when we reach the end of the slides. So these are the benefits of using the OpenAPI spec. This is why OpenAPI spec. Let's look at a OpenAPI spec file really quickly. That will actually clear a few things out for you. I have just created a random single file over here, right? Let's look at an actual OpenAPI spec file. This is a good reference at the end of this slide. This is the ListMonk project by Kenath, who's the CTO at Zerodha. They have a project called ListMonk. They want a very similar use case, KR. We want people to directly hit the backend without going through a UI. So they have created this collections.yaml file. If you look at this file, it says this file uses the OpenAPI spec version 3.0.0. This is one of the servers that you can hit. This is the base URL. Of course, this changes in production. In production, it will probably be something like api.listmonk.com. Some metadata, some tags, feel free to ignore. The most important thing is paths. They say that the backend has a /health endpoint, which is a get endpoint, which returns responses of 200 status code with description that looks like this, and content, which is JSON, which has a property called data, which is of type Boolean. This is the single endpoint that they expose. What is another endpoint they expose? A /config endpoint, which is also a get endpoint, which also has a response that looks like this. The data for this is a little more complicated. The data for this one was fairly straightforward. It returns a true or a false. If you go to api.listmonk.com/health, which is the first endpoint over here, the data that you get back is a simple Boolean, true. Okay, the backend is up. If you go to /config, the data that you get back is a little more complicated, which is why it has been referenced to a schema. KR, if you hit the /config endpoint, of course, this is not the exact URL, but if this was, then if you hit the /config endpoint, you will get back data that looks something like this. Server config is described at the end. It is an object which has a property called data. So, if it looks something like this, let me open this on the side. Let me JSON validator, something like this. It will have a field called data, which will have a field called messengers, which will be of type array or string. So, messenger one, another array, and then langs, which probably is the languages that they support: English, Punjabi, Chinese, so on and so forth, and so on and so forth. Like they describe, if you hit the /config endpoint with a get, this is the description of this endpoint, returns the general server config. And what is the response that it returns? It returns a 200 status code, the content of which are of type JSON, and the data is referred at the end of the file. Eventually, we will be creating our own OpenAPI spec file. So if this feels a little complicated, don't worry, we'll be creating our own. I just wanted to show one OpenAPI spec file in production. As you can see, it's a very long file, does not end, 4,000 lines. And that will happen whenever you want to put all your endpoints in a single file. Of course, it will be a very long file. And what is the benefit now of maintaining this file? Given they have a file that exposes the shape of all of their endpoints, I repeat, this file exposes all of their endpoints. There is a /health endpoint, /config endpoint, /lang, /any language endpoint, /dashboard /charts endpoint, /dashboard /counts endpoint. All of their endpoints they have exposed here. This is not their express file. This is a simple txt file, simple YAML file, which states that ye endpoints hai hamare. These are our endpoints. If you want, you can hit them. The beauty of this is that you have all of this in a single place. You can run a command and generate a very nice documentation page like this. What is this documentation page? It has just all of the endpoints exposed, right? There is if you send a post request here, this is the body that you can send. These are the parameters that you can send. This is the response that you will get back. And that is so clearly described here. If you hit the /health endpoint with a get request, this is the response that you get. So given this file, it's very easy to auto generate. What do I mean when I say auto generate? I mean run a command and get a very nice documentation page for yourself. That is the benefit of using the OpenAPI spec. The OpenAPI specification is a standard language agnostic interface to RESTful APIs, which allows both humans and computers to discover and understand the capabilities of a service without accessing the source code. This much is great to understand the power / use case of OpenAPI spec. It is a standard. What does standard mean? It means that you have to follow this. You can't just be like a paths. No, I will call it routes. No, it is a standard. You have to follow it. If your backend has 5 paths, they need to be in the paths endpoint or paths key. You can't randomly be like, no, I will to write routes key here. So it is a standard. You have to follow it. Language agnostic interface to RESTful APIs. ListMonk is written in Golang. We will be writing our code in Node.js. This file remains language agnostic. This file is like, tell me your endpoints that you exposed. If a Node.js code and a Golang code both have similar endpoints, they can have the same OpenAPI spec file. If they both actually expose the exact same shape, get endpoint at /config returns something, and the other one also has the same HTTP endpoints. Of course, this will use Express. This will use some other Golang HTTP framework. But if they're exposing the exact same things, then they can share the OpenAPI spec file. Both of them can use the same spec file, which makes it language agnostic interface to RESTful APIs. These are the RESTful APIs that we've written. This is a language agnostic interface to it. What does interface mean? A place where it's written clearly, these are the endpoints that we expose. For both humans and computers to discover and understand the capabilities of a service without accessing the code. I don't have to share my Node.js code with you or my Golang code with you. I will share this with you. You as a human can read it. We just read that they have a /health endpoint, a /config endpoint. Machines can also read it. You can have a machine that auto discovers, as in a good idea of a machine is ChatGPT. Okay, if you have an AI agent, all you have to give the AI agent is this file and it will understand कि okay, I need to hit the get endpoint to get back a certain response. This is how, if you ask ChatGPT what is the weather right now, it is able to hit a weather API, because whoever is the owner of that weather API, let's say it's called weatherapi.com. Whoever is the owner of this weatherapi.com has exposed their endpoints via an open API spec file. That is how a agent can also understand, an AI agent, as in a computer can understand the shape of your backend. Allows both humans and computers to discover the capabilities. When properly defined via OpenAPI, a consumer can understand and interact with the remote service with minimal implementation logic. Harkirat, again I'm confused. A consumer can understand. A consumer can understand. They can read the file. I was able to read the file. I was able to understand कि अच्छा इनका backend has a /health endpoint, has a /config endpoint. I am able to understand and interact with the remote service with minimal implementation logic. What does this mean, Harkirat? How can I interact with them with minimal implementation logic? And the answer is in this slide, auto-generated clients. If you have the OpenAPI spec file for someone, right, you can automatically generate an implementation to talk to them. That is what this line means. A consumer can interact with the remote service with minimal implementation logic. We will get to this in the last slide. This is super interesting. But let's defer this part to the last slide. Developed by some company, later donated to someone, yada, yada, yada. That's the official definition. Parts of a spec file. I showed you a very complicated spec file. Let's not look at such a big spec file. Let's look at a spec file for a simple Express code base. Okay? This is a very simple Express application. Import Express from Express. Const app equal to Express. This is a port. app.useexpress.json. An in-memory array of users. Okay, there are 2 users currently. No need for a database. Keeping it simple. And a single endpoint. app.get /users, a single endpoint that is export. What does this do? It gets the name from the query parameters. So eventually whoever is hitting this endpoint will hit it something like this, /users ? Name equal to Harkirat. Gets the name from the query parameters. And if the name exists, finds the user with that specific name. That is what this line does. Users.filter user.name.toLowercase.includes name.toLowercase. So if there is a match with any one of the names, it returns them to the users. Else returns the list of users. It looks a little weird. It should not return. This code should be slightly better. Else it should return, some null, some error, so on and so forth. But okay, this is fine. It returns an array of users who have a name similar to that person. If the user gives no name, then I guess it returns all the users. Makes sense. So if the user says ki yaar, I want a person whose name starts with HAR or whose name is similar to HAR, then it should return them all the users whose name is Harkirat, Harpreet, Harman. But if the user gives no filter, then you return them all the users. Fairly straightforward endpoint. And finally, you listen to the put. We don't have to worry about the implementation. We have to worry about, okay, given this code, what should the OpenAPI spec file for this look like? It has a simple single endpoint. So it should be a fairly easy OpenAPI spec file. This was a very long one, Harkirat. Had multiple paths. But this one has a single simple path, /users. So the OpenAPI spec file should be straightforward. And it is. If you look at it, what does it say? We are using the OpenAPI version 3. Some information, metadata, ignore. The paths. We have a /users path, which is a get endpoint. Here is a summary for it. Here is a description for it. And the parameters are, we have a query parameter called name, which is of type string, which is not really required. So is optional. And this is a description for it. And the response returns a 200 status code with the content being an array of type components /schemas /user. And then at the bottom, we have defined our user schema. Here, the user is of type object and it has an ID, which is an integer, and a name, which is a string. That is how I would write the OpenAPI spec file for this Express code. Harkirat, this looks decentish, but a little difficult. I can write this. But writing this is going to boggle my head. Are you saying I have to write this by hand? कि हाँ slash users get, what if I miss something here? What if ever there is a code change? Users gets a third field called last name. Then I have to change the OpenAPI spec file also, add another third field over here called last name. That is a good question. And that is why you usually never write the OpenAPI spec file yourself manually by hand. You auto-generate it. We'll get to how you auto-generate it. But let's see the power of the OpenAPI spec file jaldi se. Let's copy this and let's go to, let me create a simple Express application, copy all this code, run it locally. We're at 20, I guess, I don't know. npm init to initialize an empty JavaScript project, npx tsc -- init to initialize an empty ts config. By the end, I have a package.json and a tsconfig.json. Index.ts file, I'm going to just paste all the code here from here. Feel free to use Visual Studio Code, doesn't matter. I can open this in Visual Studio Code. Let me actually do that really quickly. File open. Week 20 offline. This is the code, and what is the last thing to do? npm install express at types/express. Wait for a few seconds and all the errors go away. Fairly simple code base. There is a type error here, which feel free to TS ignore for now. And let me run this code and tsc-b to compile it, and then node index.js to run it. I have it running on localhost 3000. If I go to localhost 3000 !name equal to 123 /users !name equal to 123, it says there is no user whose name starts with or has 123. But if I type John, it tells you there is one user whose name is John Doe. If I type Jane, it tells you there is one user whose name is Jane Doe. If I type J, then it will give me both the users because both of their names are similar or like have J in them. That is how the backend runs. But the backend we have done many times. Show me the benefit of the OpenAPI spec file. Good question. Let's open the OpenAPI spec file for this. Let's copy over this code and let's paste it in the same folder somewhere. Let me create a file called OpenAPI spec.yaml and paste the spec file over here. Okay, Harkirat. So you have all of your actual implementation that you will not share with the world here. You have your spec file over here that you can share with the world. It just exposes the shape of your backend routes. Here there is a /users endpoint. Doesn't really share the actual implementation logic. Yes. But Harkirat, what is the benefit of this? क्या हो गया इसको मिलके? Other than people reading through it. As I said, you can automatically generate clients. You can automatically generate documentation pages that look as pretty as this. You can automatically generate Swagger pages that look like this. Harkirat, Swagger page. What is a Swagger page? This page right here. You can create a page like this so that you don't have to hit Postman. Harkirat, can you show me? Sure. I will have to Google though. Node.js create express expose Swagger page given a OpenAPI file. I'm sure there is a npm module that just lets you do it. There you go. Swagger UI Express. I can just add Swagger UI Express as a dependency. I just need to ensure it takes a YAML file as an input because right now it takes a JSON file. How to load a YAML file? or I can just convert this into a JSON, either works. So the good thing about OpenAPI spec is you can write it in the YAML format, but in case you are confused with this YAML format, you can also convert this into a JSON format. Let me paste the YAML format here on the left, and I get the JSON format here on the right. Let me create a OpenAPI spec.json file, paste it. It's the same as the YAML file, only rather than the key value pairs looking like this, they look like this. Name on, oh, looks like the wrong one. Copy, paste, there we go. It looks something like this. OpenAPI version 3.0, OpenAPI version 3.0. The info has 3 keys, title, description, version. Info has 3 keys, title, description, version, so on and so forth. So it's basically the same thing converted into JSON. And the good thing about the OpenAPI spec is you can create it in YAML, create it in JSON, doesn't matter. It's a specification. As long as there are key value pairs, it doesn't matter. Why did we convert it into JSON? Because the library that we are using, which is going to be the Swagger UI Express, expects it to be in JSON format. So that is why we had to use it. Now let me copy this code. Let me paste it here from ./OpenAPI spec.json. Let me convert this to a JS file or TS file, and then just export this. Export const OpenAPI spec equal to this thing, and let me import it here. And then what is the last thing I have to do? app.use/documentation. Cool. What did I add? I added a new dependency called Swagger UI Express. The name itself says Swagger UI in Express. What is Swagger? It is this project that sort of, became very popular, that basically gives you this UI that looks like this. So that is why it's called Swagger UI Express, the project name over here. And if you add just this line of code, import your OpenAPI spec in the JSON format. I repeat, this is the OpenAPI spec in the JSON format, which has all of your paths. Right now we just have a single /users path. As long as we have that path and we do a app.use/documentation, swaggerui.serve, swaggerui.setup OpenAPI spec, it will serve our documentation. So if I rerun tsc-b and node index.js, you will see the /documentation endpoint has a Swagger page. It has a page that looks like this, that exposes all of my endpoints and my schemas. It tells me the user has an ID and a name, which is an integer. This is a string. But more importantly, it lets me see all of my endpoints and actually hit them without going to Postman. I can try out my endpoints here. If I give it a name called J, click on execute, it returns me these two things. Very similar to what I was doing in the browser. I can, go to the browser and do the same thing. But as you know, browser can only send GET requests, cannot send POST requests. For the same reason we used to use Postman. So rather than using Postman, you have this Swagger page that you can just share with the world. Okay, these are all of our endpoints. Please hit these endpoints in case you want to, programmatically access our backend. That is one way to auto-generate something. As I said, you can auto-generate UIs that look like this, proper documentation pages. You can auto-generate clients. You can auto-generate Swagger pages like these with a single file. To revise, what did I do? I created a simple backend and I, by hand, created an OpenAPI spec file for it. I first created it in YAML. Then I converted this YAML into JSON. And then I exported this. Harkira, you did not create it. You copied it from somewhere. You did not write this yourself. Are we expected to write all of this, such a big thing ourselves? No, you are not expected to write it. This gets auto-generated from your code. As long as you've written your code, there should be a way, if you use very good TypeScript, to figure out that there is a name endpoint and what it is returning is, users which have this shape. So you don't have to write this by hand. We will see how you can auto-generate the spec file. But do we understand the benefit of the spec file? Okay, given we have the OpenAPI spec file for an Express server, by adding less than 1, 2, and 3, less than 3 lines of code, I was able to create a page that looks like this, that lets me hit certain endpoints, or all the endpoints of the backend. As I add more endpoints here, let's say I introduce another endpoint called app.postUsers, and I do update it here as well in the OpenAPI spec. Let me update it by hand for now. As I said, you don't always have to update it by hand, but let me for now do it. Okay, bhai, there is a post endpoint as well. Now if I rerun it, I see a get endpoint. I see a post endpoint that I can hit as well. If I try to hit it, again, the implementation for the get and the post is the same. So, it will do the same thing. If I give it a J, it will return me an array. But, you can get more complicated. You can change the parameters. You can have something in the body, so on and so forth. Right now, the post endpoint, doesn't really access the body. But yeah, you get the idea. As your project becomes bigger and bigger, so does your OpenAPI spec file. And that is exactly the reason why the ListMonk OpenAPI spec file is so huge, because it has so many endpoints. Cool. That is slide number 3. The parts of the spec file. Specifically, the parts you have to focus on is all your paths and all of your schemas that are associated to paths. Okay, the get endpoint for /users returns a user schema. All the reusable things you throw over here, so that you can use them across various endpoints. For example, I just introduced another endpoint over here, right? I introduced the post endpoint. I can reuse all the items in this array are going to be of this user type that I can describe separately here. I could have totally been like, the type of this is going to be, this, but that's just, repeating the code again and again. I will have to write the same thing in 2 places, which is why it's generally a good idea to just extract everything out into schemas and then, reuse the schemas everywhere. So what are the 2 things to learn? Schemas and paths. Paths are all of your routes. Schemas are all of the shapes of the inputs, the outputs that you want extracted out so that you can reuse them in various paths. That is the parts of an OpenAPI spec file. Okay, Kirat, extremely complicated file that you can create. I don't want to create it myself. I want to write my backend code. I want someone else to create it for me. I want it to be auto-generated. Seems extremely unoptimal for someone to, write this by hand. They will make a mistake while writing it, and then, the OpenAPI spec file will be screwed. That is true. How to create a spec file? You can either write it by hand. It still happens. If I'm not wrong, this one is actually created by hand, believe it or not. I don't think this is auto-generated yet. At least it wasn't up until 6 months ago. Might have changed now. So a lot of people write it yourself, like by hand. Look at the code and then write the endpoints here. Not the best idea in the world. Auto-generate them from your code. This is actually very easy in a language like Rust, where the types are so ingrained and so strict throughout. Okay, everything needs to have a described type. So you don't have to do much. You just have to add a trait and you immediately get the OpenAPI spec. That is how it happened at Backpack. Backpack backend was in Rust. And if you look at the documentation page here, Backpack Exchange docs, this documentation page was auto-generated from an OpenAPI spec file. This one right here, as you can see, very similar, get balances, get deposits, send a call to the specific endpoint, so on and so forth. So in a language, if you're using Rust as your backend, then it will be very easy for you to introduce the OpenAPI spec file. Slightly harder in languages like Go, and this should be JavaScript, Go and JavaScript, because it's where, the types aren't so ingrained in the code base, which is why you usually have to add something extra. You usually, whenever you're writing your code, right, you have to add something extra. Okay, what is the extra thing you have to add? Something like this. You have to go something like this. Okay, given this endpoint, this is a get endpoint for the /users route. The input is, whatever path, which takes a name as an input, which is a string, and then output, so on and so forth. Like, you have to be very verbose while defining all of your endpoints. You define your endpoint and you define some code on top or some comments on top. These comments automatically generate the OpenAPI spec file. This is one way of doing it. Okay, every time I'm writing an endpoint, whoever is the developer writing the endpoint, it is their responsibility to make sure that the comment is also updated. If they change this to, accept name and age, then they need to update this comment as well, because the OpenAPI file, this file right here, is generated based on this comment. This is one way of, auto generating clients. Auto generate to nahi, this is to isn't auto generated. This is just you, rather than writing it here, writing it over here. That is correct. This is not really auto generated. Auto generated is here I write nothing extra. Given this code, somehow we are able to generate this file. This is actually a very tough problem. Might feel very easy. Ye to raha code. This is the code right here. Why can I not understand, like go through the code? Why can't an algorithm not read the code and figure out and create the OpenAPI spec file? And the answer is, as I said, unless you have very strict types everywhere, which we don't over here, it'll be very hard to purely based on extracting the code, figure out the inputs and the outputs, which is why you can actually, use code bases and libraries that let you auto generate code. In fact, in cohort 1, we use a library called TSOA that lets you add TypeScript annotations. So things like, add route, if you've heard of annotations. If not, that is fine. This video will be uploaded to cohort 2. It covers in fairly detail how to add annotations to TypeScript and how you can use them if you're using the TSOA library. Or Hono has a native implementation with Zod. If you remember, Hono is a framework that lets you do HTTP. So it's an HTTP framework, very similar to Express, and it has an implementation. It says, if you want to use the OpenAPI spec, just describe your schemas very strictly using Zod, and I will take care of generating the OpenAPI file. That is another thing you can do. There is no right or wrong approach. The comments approach is also right. The using annotations like these and using something like TSO is also right. You can also do it natively in Express. This also will require you to, be a little more verbose when writing your endpoints and, describe things like this. Or you can use Zod OpenAPI. So feel free to choose what is more, like what serves your use case better. Generally, if you have a use case where your backend needs an OpenAPI spec, you will use Rust or, a language that is more type safe, or more specifically not type safe, has very explicit types everywhere. So it's very easy to generate an OpenAPI file, versus in Golang and JavaScript or TypeScript, it's slightly harder. This we have covered in cohort 1. There is a cohort 1 video if you want to do it this way. If you want to do it using Hono, then that is what we will discuss in this slide. How can you use Hono plus Zod plus the OpenAPI spec and, create a backend which will auto generate this OpenAPI file. Let's get into that next. All right, let's get to the real coding bit now. Let's understand how can you create an HTTP endpoint with auto-generated OpenAPI spec using Zod OpenAPI. Hono folks realize this is a common pattern and, might be good to provide this out of the box so that all you have to do is write some code. You don't have to write any extra, documentation, any annotations. You just write some code and that auto generates the OpenAPI spec file. Let's see how they do it. Firstly, you have to initialize a simple Hono project. Let's do that first. What was the way to initialize a Hono project if you remember from the Cloudflare classes? It's npm create Hono at the rate of latest. So let's create a fresh Hono project, call it week 20 offline 2. Any framework runtime is fine. Node.js is also fine, but let's stick with the Cloudflare workers because that's the one that we're most comfortable with. Let's install all the dependencies and use npm is fine for now. Feel free to use bun or yarn. And let's open week 20 offline 2 in Visual Studio Code. Now we have a simple Hono application, but we have to write it a different way. You can't auto-generate an OpenAPI spec file with such simple code. You need to have very strong types so that whatever is auto generating your code is able to figure out the types and create the final OpenAPI spec file. For that reason, if you look at the Zod OpenAPI documentation, you'll see it says Zod OpenAPI Hono is an extended Hono class that supports OpenAPI. With it, you can validate values and types using Zod. So you will still use Zod for validation, but you can also generate the OpenAPI documentation purely because you're, giving very strong types at compile time. You're telling it, these are the types, not compile time, runtime, but you get the idea. You're giving it very strong types before defining your schema or before defining your route. So the OpenAPI file is generated automatically. Too much jargon? Yes, I agree. Let's get into the code. The code says, if you want to create a route, you should first describe what the inputs are. Is it a query parameter? Is it a body? Is it a header? What the outputs are? What does the route return to the user? And then finally, you create your route. Okay, this is the method. This is the path. The request has these parameters. And the response, there's just one response, 200 status code, which has this schema. You write this in a highly verbose fashion. What do I mean when I say verbose? I mean, you have to write a lot of code so that by the end of it, your OpenAPI file is automatically generated. Finally, when you have written this route, then you create a new OpenAPI Hono app. You do not create a new Hono app like we did over here. You use the extended class called OpenAPI Hono. You create an app using it. You describe all of your routes over here. For example, there is the first route that we have written. We might have more routes in the future. And then you say, bro, all the documentation is exposed on the /doc endpoint with some extra metadata information. Okay, the OpenAPI spec version is 3.0 and the title is this, so on and so forth. So let's write this code and understand this a little bit better. There are a lot of moving parts to this. This is very verbose. OpenAPI spec is not the best thing to write in TypeScript because you have to write a lot of code for a single endpoint. A single endpoint that should have been, fairly straightforward. Okay, whatever c.json and then just return the user details now becomes highly verbose because you have to tell what is the input, what is the output, and use Zod to define that very strictly. Let's see what that means. Number one, let's install the dependencies. We have a add hono /zod OpenAPI. So let's add that dependency. Do we have any other dependency? No, we don't. Once that is done, let's clear this and let's start from the top. We first have to describe the inputs for our route. So we say import Z, not from Zod this time. Usually we've done this, import Z from Zod, and we used to define the types. Now we have to import Z from @hono /Zod OpenAPI. Describe your input schema. Whenever my first endpoint is going to have schema that looks like this, const params schema equal to Z.object. It'll have an ID, which is a string with minimum length 1, maximum length 10th, let's say, and .openAPI. Describe क्या OpenAPI file में let's call this name ID and it's present. Where is it present? Is it present in the body? Is it present in the path? It is present as a query parameter, not even a query parameter. It's just present in the path over here /user/ID. And if you want, you can give it an example as well. That will appear in the OpenAPI spec file. If not, that's fine as well. This much code is just for the inputs from the user on the route. This much code is just to describe the inputs that the user will give in the routes. What do we have to define next? The output schema. What does the endpoint return? Const user schema equal to Z.object. Again, I'm just copying it from here. I don't know this from memory. Would be nice if I did. Gives me some options: name, age, and then maybe ID, which is again Z.string.min1.max10. open API, example 24. Missing something obvious here. Number is not definable to string because this is a string over here. Let's make it a number. Let's keep it string. There you go. All right. Inputs, output from the route. Kira, this seems extremely verbose. Should we keep it into a different file? Maybe. You can define a separate file called inputs.ts, separate file called outputs.ts, and make this slightly cleaner. Let me export the inputs from here. Export const paramas schema equal to this thing. And then the outputs I can export from another file. Given that the inputs and the outputs are exported, now I can ensure that the meat of my logic is here. Here I only write the route handler. What is the route handler? Let's look at that next. Import create route from @hono/zod OpenAPI. Const route equal to, this is similar to app.get, app.post in Express. Okay, by this is a get endpoint with this path right here, with the request being of type params schema, which comes from /inputs, and the responses, we only have one response, which will be a 200 status code, the content of which is of type JSON, and the schema of which looks like the user schema, which comes from the outputs. And if need be, or I think this might be necessary to give it a description, get the user's details. This is how you can define the first route. You can call it the get user route. You don't necessarily have to call it route. Probably should call it the get user route. This can also be in a separate file called routes, but I think this is good enough for now. Lastly, you create your app. Const app equal to new OpenAPI Hono, and then app.openapi route. Whenever this route is hit, this should be the handler for it, and then here you can do whatever you const id equal to rec.query c dot rec dot get param, which means this parameter right here, and then return whatever c.json id age, like some random dummy data. Cannot find route because it's called get user route, and that's how you register your very first route. Harkiyat, if I have more than one routes, then you can describe multiple routes, right? You can have a post user route, which is a post on the same thing, and then you can describe its implementation here. App.openapi so on and so forth. So let's say I have two endpoints right now, a get endpoint and a post endpoint. Both of them share the output schema, and both of them also have a similar sort of input schema as well. Let's see if this works in the first place. The first step is, does it work? We'll get to how it generates the OpenAPI spec and what this line over here does. Let's copy this line, but let's not worry about this line just yet. app.doc/doc and these metadata associated with this OpenAPI spec. Let's see if it actually does what it's supposed to do. Let's run npm run dev. And let's go to localhost:8787/ what is the route? /user/id. So /user/1. It says ID, your ID, age, and name. If I remember correctly, params schema had some restrictions. Minimum 1, maximum 10. Let's make minimum 3. Let's change the Zod schema and let's see, does that fail it? It does fail it. It says success false, code too small, minimum 3. So I have to now pass in an ID that has at least 3 characters. And if all of these XORD validations succeed is when, the control reaches the final route handler over here, which is handling the get endpoint. Can we do the post endpoint as well? Yes, we can. We can go to Postman, or you can generate a Swagger page just like I will show in the next slide. But you can also use Postman for now, send a post request, and it also returns you the same thing. So that is how you can create multiple endpoints and have very strict XORD validations on the inputs and describe all of your outputs. Why? Why would you want to describe your outputs? So that the OpenAPI spec can automatically be generated from it. Now, if I go to the /doc endpoint, you will notice it has my OpenAPI spec. It says there is one path called /users/ID, which has get, which looks something like this. And it has a post, which looks something like this. We have a auto-generated OpenAPI spec file. And now you can do 10 different things with it. You can add Swagger to it. You can automatically generate clients from it. Let's see how that happens. That's the next slide. But what did we learn in this slide? How can you write some code that will not just create an HTTP endpoint for you, /users/1, not just create this endpoint and have very strict validations here. It will also generate your OpenAPI spec file. Given we have this OpenAPI spec file, let's see how can we generate a Swagger UI for it. Thankfully, these guys have already created a @hono/Swagger UI package, so you can simply use it. If I go back and I do a npm install @hono/Swagger UI, copy this and add this /UI endpoint at the very end, maybe somewhere here. app.get /UI, Swagger UI, URL/doc. Now if I run npm run dev and if I go to 8787 what was it? UI, I see the Swagger page. It shows me you have 2 endpoints on your Cloudflare worker. I can also interact with it. Again, this page was automatically generated. I did not have to create this page specifically. That is what the next slide probably was, creating a Swagger page for it. Now that we understand, how can we, I don't know if you can understand it yet because it's always, as I said, very hard to write OpenAPI compliant routes, especially if you want to automatically generate OpenAPI spec files. This is very complicated. If you go through the cohort 1 video where we use TSOA, that is also fairly complicated, which is why usually you use a language like Rust if you want to create an OpenAPI spec file automatically given a code base. But if you understood this, let's understand auto-generated clients a bit. What are auto-generated clients? If you remember in the definition of OpenAPI spec, I said a consumer can interact with the remote service with minimal implementation logic. Let's understand what does this mean. Okay, given there is a service, there is a backend, let's say, this one right here. How can a user interact with it with minimal implementation logic? Hakikat, I know I can interact with it with minimum implementation logic because I don't have to go to Postman. I can directly go from here. So is that what it means? Not exactly. Minimal implementation logic means, if you want to hit these endpoints via, let's say, Golang, a Golang process, or in a React process, or in a Node.js process, or in a Rust process, how can you, in minimum lines of code, directly talk to this? Harkirat, I don't understand. What do you mean minimum lines of code? Let's go to the dashboard. You have a Hono server, or, doesn't matter if it's a Hono server, it's an Express server, doesn't matter. Let's say it's a Hono HTTP server. And you don't just have the server. You have somehow also automatically generated a OpenAPI spec file for it. Where does this come from? Don't worry about it. As we saw, it was automatically generated, but this file is, available on /doc. This very big OpenAPI file that we saw is already available. Given that you have these two, and let's say you're a random trader. Let's say this backend is for a trading application like Binance. This OpenAPI spec file is for the same application, and you are a trader who has a C++ application or a Rust application, low latency Rust application. How can you talk to this server given you know this file? Harkirat, I will read through this file I will understand ki acha there is this endpoint. I will write code over here. If this was Node.js, then I would have code like this: axios.get/user/1, and cons response equal to await this, so on and so forth. That is how I would write my code in Node.js that is able to talk to the HTTP server. You could write this, but what if I tell you could automatically generate a client? Harkirat, client? What do you mean client? I mean, what if given this OpenAPI spec file, I created a library for you, very similar to Express, called Binance client, let's say, and I wrote all of this code for you. ये जो express equal to await axios.json है, I wrote it for you over here. And then in your Node.js process, all you had to do was call a function, Binance user fetcher with the right arguments. What if I automatically generate a client for you given the OpenAPI spec file? Forget that the trader is writing some Node.js code. Isko nikal do. Forget that the trader is writing some code. Before they even write some code, wouldn't it be nice if, given the OpenAPI spec file, you are able to create something like this? A library that says, get user, takes an ID as an input, and then, you are able to hit that ID. What is the benefit of this, Harkirat? Why would I want to create a Binance client? What did the slide say? The slide said, with minimal implementation logic. The final trader who wants to interact with, this is the trader who has a Node.js process, who wants to talk to the Hono server, they now can simply call a function. They have minimal implementation logic. They don't have to worry about, acha, there is a post request or a get request. They simply call a function, and under the hood, all of this code is automatically generated for them. That is what a automatically generated client is. Here, given you already have all of this, there should be a way to parse this file. There is one endpoint which has a get thingy and also has a post thingy. So there should be a way to parse this file and generate a client automatically, generate a Node.js library automatically, or a Golang library automatically, that someone can directly use. They don't have to write the const res equal to fetch. They will simply call get user, and then all of this logic is already written for them. That is what a automatically generated client means. Let's see how that happens. Given you have this very long OpenAPI spec file, this will be your input always. This is your, if you want to automatically generate anything, right? Be it Binance docs, a page that looks like this, or the Swagger page that I showed you, or even the clients that we're talking about, the source of truth for all of them is this documentation page, or sorry, this very long file. So given you have this file, you can generate 100 different things from them, because the person has told you, yeah, these are my backend endpoints. Create whatever you want with it. And what are we creating? We are creating a simple Node.js client for it, a Node.js library which exposes a few functions like get user, and then maybe another function called, post user, purely based on the OpenAPI spec file. So let's copy the OpenAPI spec file, paste it anywhere, doesn't matter where. Let me paste it here, call it spec.json. And given I have this spec.json, I can use what's the library called again? OpenAPI TypeScript code gen. What is the library called? By OpenAPI TypeScript code generation. I can use this library and run this command, npx OpenAPI TypeScript code generation. The input is this spec file. Please generate an output library for me in a folder called generated. I can run this command and this will generate a client for me. What is this library doing? This library is going through the spec.json file, understanding that these are the two routes. There is a get route, there is a post route. And then, given it knows that there are these two routes, it is finally generating the folder which has your Node.js client, which has what? Which has this code right here. Let's try to run it and explore what it creates. Let me run the command. spec.json is here. It says there's an error because cat spec.json. Let me recreate spec.json. Let me create it here. Doesn't matter where you create it, but let me just create it here. Spec.json. Paste it from here. Looks good. npx OpenAPI TypeScript codegen. Input is spec.json. Output is /generated. It did work and it created a generated folder for me. This has now, as you can see, a lot of TypeScript logic. It was able to create a client for me. What is a client? A Node.js library, a JavaScript library for me, which exposes something called a default service, which is a class which has a get user function, which, as you can see under the hood, sends a get request to /users/id. If I hover over this, you will see it, eventually will send a fetch request. Send request. There is a fetch over here. So what is happening? I was able to generate a default service which has a get user function that I can use in any Node.js process of mine. Let's try to use it here. Let me do a import default service from /generated const service equal to new default service, and I can do a service.get user, or probably default service.get user. Yeah, it's a static file, so something like this. One const response equal to await this thing, and then let me return whatever. Like, you can use this. I don't want to use it here because this is the same. This is the same function that the same index.ts file that starts the server. You shouldn't start the server and it shouldn't talk to itself basically. This default service should be used it shouldn't be used here. Right now I'm writing it कि भाई जिस server से बात करनी है, the server that we're talking to is using this client to sort of talk to itself. So I shouldn't do that. I should create a fresh Node.js project over which you can use this generated client. And that way you can, you don't have to write, const response equal to await fetch, go to the localhost colon. What was the endpoint? Achha, it was localhost 3000. So what is the actual endpoint? /user/1. And so what all do I need to send with it? I need to send, let's say, some header. You can simply call a function and with minimal implementation logic, talk to the other service. That is what a auto-generated client is. This default service is automatically generated. And what does it do again? If I go here, it exposes a static function called getUser, where I can pass in an ID and it under the hood will send a get request to /user/id. So that is what auto-generated clients are. Thoda sa, little bit, try to iske baad create a fresh Node.js project, use this generated client over here. Let me do it really quickly. Let me create a fresh Node.js project, call it trader app, let's say cd trader app, npm init-y, npx tsc --init. Let me copy over this generated folder that I had, which has my auto generated client, cp:/week 20 offline 2 /generated over to this folder. This will copy it. And now I have this fresh trader application. Let me open this trader application and, try to write some code there. That's ideally how you would, that's ideally where you would trader app. Create an index.ts file and you can be like, default service.get user of 1 const response equal to await of this, and then, console.log response, put it in an async function, and then call the async function. This is a trader application. This is what? This is this thing right here. Did I have to write any logic to talk to this directly? No, I used minimal logic from another library that is automatically generated to talk directly to the Hono HTTP server. So if I now, number 1, start the Hono server. So week 20 offline 2 npm run dev. I have it running on localhost 8787. And now if I run this trader application, I can just convert it to JavaScript for now because there are some TS errors over here. Actually, that might not work. This is in TS, right? mv index.js to index.ts. Let me see if I can quickly fix this. If not, I will leave it as an assignment. What is the error? I can also try ES build. ES build. Index.ts. It did generate it. So let's create an out file and node index.js. Failed to parse URL because I don't have a config URL in generated. Let's quickly add that. OpenAPI config, the base URL should be http://localhost:8787. I'm sure you can define this in the week 20 this thing as well, like somewhere here, cat source/index.ts. Maybe if you go somewhere here, you should describe the base URL as well. Since we did not describe a base URL, it was empty over here, so it was not able to hit that service. Let's recompile it with the base URL set and run node index.js. And it still says connection refused because nothing is running here. Let me run npm run dev, and then if I run node index.js, it says 400 bad requests, too small. I am sending too small an ID. Let me send a correct ID. Let me try that one more time. npx es build followed by node index.js, and it returns me the right response. So I was able to hit someone else's service without writing this. What was the other way to write the same thing? Await, fetch, http 8787/user/123. I can still do this. Like this also works. Or I can totally do a npm install axios and then do a await axios.get this thing, and then console.log rest. That works as well. There's nothing wrong in that. Only that isn't minimal implementation. Here you had to actually understand that I have to write an HTTP call to this endpoint. Versus if you use the automatically generated client, you don't have to worry about, I have to send an HTTP call where. You simply call a function. The function takes care of, actually sending the HTTP request under the hood. That is what a automatically generated client is. Little bit confused, even I would be if I was, because there are too many things happen together. But to summarize, what have we learned? We learned, number one, what is the OpenAPI spec? Why do you need it? Number two, how do you create an OpenAPI spec file by hand if you have to write it by hand? Then how to automatically generate it if you are using Hono as your HTTP framework. And lastly, we understood how to, given you already have this and you have a spec.yaml file or spec.json file, how to generate JS clients for it, so you can in minimal implementation hit the respective service. This is what we learned. The most difficult bit, I'm assuming, were last two. I think everything until here was fairly straightforward. And these two are a little different. Specifically, the most difficult bit was this, how to create this week 20 offline thingy that we created. Let me also push this somewhere so you can try it out locally. Init open API compliant backend, git remote, add origin. So if you want to just look at the code, you can look at it over here. Let's create a public repository. There we go. So if you want to look at the code, it's present here. It also has the automatically generated client if you want to look at it. But yeah, the most difficult bit I'm assuming was, writing the backend. We've been so used to writing simple backends. And by simple backends, I mean, app.get, app.post, describing first the input, then the output, then the route, and then giving it to, an app.openAPI and then exposing everything can seem jarring, totally would seem jarring to me as well. If it does, try cutting out things, try cutting out the post endpoint and try removing the inputs, make it a little more easier, and then, go from there. That'd be my only advice. Other than that, yeah, OpenAPI spec, writing an OpenAPI spec compliant auto-generated backend in Node.js is hard, which is why you use Rust. And if you're curious, like how to do this in Rust OpenAPI, it's like fairly, all you have to do is add a trait and go from there. Poem is a decent framework if you want to look at it. There you go. Poem OpenAPI. In case you know Rust, this should be straightforward. If not, that's fine. But yeah, this is one framework that makes it very easy for you to, pretty much, add some logic like this. And so you have to give it the route still, you have to give it the method still, but everything else is sort of auto-generated based on the types of the inputs and the outputs. So fairly easy way to do OpenAPI if you're using Rust. With that, let's end it. I'll see you guys in the next one. Bye-bye.